everyone. Apart from friends in Hong Kong and India, we have also friends from Taiwan who would like to share us more on the open source issue. We will now pass our mic to Kat, our colleague in Taiwan, for the following 4 sections. Hello, Kat.
Hello, everyone. Hi. We are from COSCUP, Taiwan. COSCUP is the biggest open source conference, and in this year, we will hold the event on August 1st and 2nd. Welcome to join our event. Now, the SZ will share his talk, Build and Maintain Civil Infrastructure Platform by Using Open Source Project. The Civil Infrastructure Platform develops the software for civil infrastructure projects by using open source projects. And the Open Chain project defines the key requirements of the Quality Open Source Compliance Program. And SZ will share how these open source projects make the human life better. Please, SZ.
Hello everyone, it's my pleasure to meet all of you in the air. So today I would like to share with you the topic is build and maintain civil infrastructure platform by using open source projects. My name is SZ Lin Shangzhi. I work for Moxa, an industrial company in Taiwan. Currently, I'm the member of the CIP, Civil Infrastructure Platform Technical Steering Committee, and a member of the Open Chain Governing Board. In my spare time, I contribute in Debian. I maintain and collaborate with upstream programmer and to make the human life better. So, civil infrastructure. You may have curious that what is civil infrastructure? Try to imagine that. How do you go to work every day? You may take the bus, you may take the railway, or etc. That is the civil infrastructure. The first is transport. As you can see, the railway automation, vehicle control, automatic ticket gates, energy, the power generation, or some power control devices. The next one is others. For example, healthcare, building automation, broadcasting, and industrial, such as CNC control, industrial communication. Those are kind of the civil infrastructure, but there are some challenges. For example, in the power plant system, the requirement in the power plant system is that it needs 25 to 6 years product life cycle. Wow, it's very long. So it's critical for us to maintain a power plant system. Another issue is security. So what if our civil infrastructure got attacked? That will be a big issue for us. So the key challenges in the civil infrastructure are we have to maintain it and make it secure and make it sustainability. So there are 3 points here. The first one is industrial readiness. We have to have the reliability, functional safety, real-time capability. The next one is sustainability. So in the civil infrastructure platform, we need products with a very long life cycle, with the longevity. And the last but not the least is about the security. As I mentioned before, it's vital for civil infrastructure platform in security. So we have to make sure the security and vulnerability management and to ensure the firmware updates is safe and to minimize the risk of regressions. So these are our requirements in the C4 infrastructure. But how? We need to solve these key challenges. It's very critical for a single company to deal with those challenges. So our idea is maybe we can choose another way. We can collaborate with each other, just cross the company, and those we can save our time, our resources to focus on differentiating products. As you can see, if you can cover these fields, we can have more resources and more time to do the differentiating stuff. So that is our idea. And we can collaborate with each other by using open source software. It's just like a language. We have a common language to speak in the project, and those we can collaborate with each other more smooth. So as I mentioned, CIP is the solution. The C4 infrastructure platform is a Linux Foundation project, aims to establish the open source base layer of industrial grade software to enable the use and implementation of software building blocks for C4 infrastructure systems. What is an open source base layer? As you can see in this figure, the CIP project covered CIP kernel. We support the 10 plus years maintenance based on the LTS kernels. I will elaborate with the more detailed stuff in this maintenance. And also we have CIP core packages. These are our base layer. And those are the company can build up their application and their innovative algorithm, for example, above the base layer. So, how to map CIP into the company? Currently, we have the CIP kernel for 10 plus years maintenance, and we have several core packages in CIP base layer. In user space, we choose Debian and Yocto as our root file system. So the company can build up their application, their innovative project algorithm above the base layer. As you can see, the company can save the time, the resources to produce more innovative and differentiation. The backbone of the CIP are the member companies. Currently, there are several companies behind the CIP project. Renesas, Siemens, Toshiba, Cothink, Cybertrust, Hitachi, Moxa, and the Platform. Yep. So the CIP will provide the budget to developers and maintainers. We will collaborate with the upstream projects. For example, the Linux kernel, real-time Linux, the Debian, reproducer build, and Edge Foundry. We collaborate with those upstream projects and try to make our software more secure and more have the high quality assurance. So this is our maintenance figure. As I mentioned, we have the maintenance in CIP kernel for 10 plus years. And for the CIP core packages in the user space, we use the packages in the Debian. Normally, the Debian will maintain the packages for 3 years, and there are extra 2 years in Debian LTS. After that, there is a Debian ELTS, and we are working with the Debian community. So, as I mentioned in the previous slides, the CIP lays the foundation for sustainable smart cities. Nowadays, we have several activities in CIP project in the Linux Foundation project. This is our roadmap. As you can see, there are 6 work group and teams in CIP now. The first one is a kernel team. The kernel team aims to support the Linux kernel for more than 10 years. We will fix the security issues such as the CVE in kernel and the bug fix. The second work group, teams is real time. So we support real time since there are lots of the real time usage requirements in the C4 infrastructure platform. And third, we have our build environment. So we have a BBAC or DBKH mechanism on that. This is the CIP core packages. The fourth teams is test automation. It's crucial to make sure the software quality in our C4 infrastructure platform. So we have the test automation of team in our project. The next one is security. As you know, there is the standard IEC 62443 focused on the ISCS security. In this work group, we focus in survey the 62443 standard and to implement it in our platform. The last one is the safe and secure update work group. As I mentioned, we may have to maintain a platform for then 10 years. So during this period, we may have lots of the bug fix or security fixes. So it's vital for us to update the component or products in safe states. So our CIP governance structure and project. As I mentioned, there are 6 teams or work groups in the CIP project. And this table maps the requirement which I mentioned before. It's regarding the industry grade, sustainability, and security. So we have the technical steering committee to discuss the technical direction and some issues from the work group or the teams. And above the TSC, we have governing board. This is currently how we work. And as I mentioned in the previous slides, we collaborate with other open source software projects. So this is the mechanism how we work, we collaborate with them. As you can see, we contribute and collaborate these open source projects. For example, the real-time Linux, the Debian, Lava, kernel CI, etc. And then we follow the rules that is upstream first. So if we find any issues, we fix any bugs or CVE or security issues, we will follow the policy that is upstream first. And then we will use the upstream code to produce our platform. Moreover, the CIP will contribute members as future candidates. As you can see, the candidates are Jailhouse, Fossology, Viego, etc. And then we can use upstream code to build up the CIP open source base layer, aka OSBL. So in the next few slides, I will introduce the workgroup and the teams in CIP individuals. The first one, as I mentioned, is kernel development teams. The goal in the kernel team is to provide the CIP kernel with more than 10 years maintenance period, which includes a bug fix and security fixes. So we call it a super long time stable kernel, SLTS. We have the mentor, Ben Hutchins. We have two maintainers, Iwamazu-san and Pavel. So the status of the kernel in CIP is we maintain the 4.4 and 4.19 kernel so far, and we released 4.19.128-CIP28 today, and 4.4.227-CIP46 version today. So we have the CV tracker in the kernel team. We will track the current CV situation in our CIP kernel. We also participate the upstream review process. You may check our resources via these two links. And these videos address how we work in the kernel team. We have developers, we have a mentor, and maintainers. We collaborate with the mainline, that is upstream. So the LTS kernel will release to public. So we will use the LTS kernel into our SLTS kernel. The next is a real-time Linux development. As we know, it's a preemptive RT. So nowadays, CIP joined the real-time Linux project as gold members. We work with them to upstream real-time enhancements. So we also have a real-time kernel version in CIP kernel. The current status in SLT real-time kernel is we have 4.19.125-CIP27 RT11 released in May 28, and for 4.4 we released the 4.4.225-CIP45-RT29 in June 2nd. You can refer to our current status in the link. So this is how we work with the stable kernel and real-time kernel. We found the real-time Linux project, and our maintainers joined the discussion with them. And we use the stable kernel and integrate it to our SLTS RT kernel. And we release the SLTS CIP kernel in real time periodically. So next one is the CIP core. It provides a reference implementation of CIP core packages for testing. Currently, we have two profiles. The first one is Tiny Profile. It's aimed to provide it to the small IoT devices. Another one is Generic Profile. It's aimed to provide IoT gateways, more powerful devices. So as I mentioned, we can check the current status via our GitLab. Our contributions is open to everyone. So in CIP core, we found that reproducible build system and Debian community, and we also contribute our effort to upstream. And then we will use the Debian packages and to integrate to our open source base layer. That is CIP core periodically. The next one is CIP testing. So this team aims to provide a test environment to test the CIP kernel and CIP core. The current status is that we moved the distributed testing environment on AWS with Lava. Lava is a tool that can deploy the image automatically in the embedded devices. We also integrated the system with GitHub CI. So as you can see in this picture, we published the result and integrated our codes to kernel CI and Lava. And after testing, we can know that the current status of our release. We can know if there are any regressions or any issues need to solved before the official release. The next one is security working group. This work group, as I mentioned in the previous slides, is to provide the guidelines and relevance implementation to help developers to meet the standard. That is IEC 62443. The standard focus on the IACS system. So we will investigate the standard and we will implement this in the CIP platform. So in the security workgroup, we have the meeting every week. So in this meeting, we discuss our thoughts. We discuss our understanding regarding the guidelines, the requirements in the 62443. The last workgroup is software update working group. This workgroup aims to incorporate a common solution for software updates into CIP core. We want our updates is safe and secure. In case any accident happened, we still have the safe update safe status in our products to make sure it won't turn to the stone. So we select open source software update tools. For example, we select software updates as well as our tools in order to update the software. So you can see our progress in the CIP wiki and our mailing list. The conclusion is our civilization needs an open source base layer of industrial grade software. Several companies collaborate with each other, and thus we can save the time resources to produce more innovative product technology. So that is CIP's goal. Moreover, we will contribute and collaborate with the upstream projects and to support them to make the high quality open source software. So in CIP project, we are open to everyone. So we have the regular meeting. The CIP has the IRC weekly meeting every Thursday on UTC GMT 9 a.m. So you can join the meeting via the IRC channel. The CIP IRC channel is open and public to everyone. The meeting time is around 30 minutes, but sometimes it's will be extended due to the some contents. So to get more information, you can subscribe to the mailing list and check the website, news wiki, or our source code GitLab. And feel free to join us. We want to provide a open source base layer for sustainable smart cities. So in the past around 20 minutes, I introduced the Linux Foundation project, civil infrastructure platform project to support our civil infrastructure. We collaborate with each other via the open source software. But how do I trust my open source supply chain? As you may know, we use lots of open source software nowadays, but how do I trust them? OpenChain is the solution. OpenChain is the Linux Foundation project. So the OpenChain aims to provide the process to make the company or the organization to trust their open source supply chain. We use a lot of open source software. So as you can see, the software supplier may provide the open source information or may not. Sometimes they provide the open source software with some legal issues, or they didn't follow the rules in the open source license. That makes some issues for us. That is the OpenChain want to solve. The OpenChain project defines the key requirements of the quality open source compliance program. The Open Compliance Program solution can be divided to 3 layers. The first one is tooling. The second one is the bill of materials, BOM. The third one is processes. Compliance is core to effective strategic engagement with open source technology. It's very important that we can use this effectively for our supply chains. So the Linux Foundation project OpenChain aims to solve these issues which I mentioned before. Currently, there are several members behind the OpenChain. As you can see, there are diverse. There are IC design companies, software companies, hardware manufacturer companies. So it's a diverse community. But we have the single goal. That is to establish the standard for open source compliance. The OpenChain defines inflection points. The upstream provides the open source software to us, and we provide our products or components to our downstream. So there are 3 main tasks we need to take care of. That is training, policies, process. So in OpenChain is defined the big picture, showing the inflection points we should have. So result is we can predict the compliance activity in B2B. So taken in aggregate, the adoption of OpenChain by companies in the supply chain can reduce the chance of errors in individual companies. So it also increases, we can predict the other company, how do they use the open source software. So everyone is asking and answering the same question. So it's beneficial to establish the requirements in OpenChain, and those we can save our effort and time in open source compliance tasks. So currently, the OpenChain specification version is 2.0, and I use my time to work with Ruzian Lin, a legal consultant in Taiwan. We translate the OpenChain specification from English to traditional Chinese. So you can get the specification in OpenChain website, which I will mention later. So I also translate the OpenChain requirements to the picture. So as you can see, regarding the conformers, is the requirement 6.1 and 6.2.1. So we need to have the documentation to address how the program can meet the specification and keep it at least 18 months. And in the organization, the program needs to have the open source policy and the open source contribution policy. After that, we need to tell the software staff. We need to notify them in various ways, such as the wiki, internal training, or email, etc. And we need to have the inquiry contact information to our maybe the customer or to the public. We also need to have the documentation regarding the awareness of the program participant and the program scope. Another documentation regarding the R&R, role and responsibility. The role competences, competence evaluation, name of role, review and remediation of non-compliance cases. And we need to take care of the development process. So we need to have the review process, release process, and contribution process in the program. For the open source artifacts, we need to obligate the open source license and the copyrights. So the open source version is vital in that, because it may change the license so in every version. So we need to take care of that. So finally, we will get the compliance artifacts in the supplied software. It's a basic introduction in the OpenChain specification. OpenChain project also provides the compliance program. So a simple logo, we have a significant meaning. The companies that meet the OpenChain specification requirements can use a badge to identify their OpenChain conformance program and the product that went through this program. The OpenChain also provides a wide range of the reference materials and translations to assist with conformers. The key reference items are provided directly on the OpenChain website. So you can get the comprehensive materials on the OpenChain websites. And the next step for the OpenChain is the OpenChain specification is under reviewing in ISO standard. So after that, we have the formal standardization. We expect the OpenChain specification 2.0 to become a formal standard in the first half of 2020. So as I mentioned in the previous slides, the open chain standard can be met by self-certification, independent compliance assessment, and third-party certification. So when it comes to meeting the open chain industrial standard for open source compliance, you can choose one of the way to make sure you achieve the open chain requirements. Currently, there are many organizations announced the open chain conformance program. So if you are interested in the open source compliance regarding the organization using the open source software, you can join our community via the link. And the self-certified or health check and organization, you can check the link to see the current status regarding the open source compliance in your organization. So we also have several mailing lists. We have the mailing list, the Taiwan Work Group, Automotive Work Group, Japan, Korea, India, Germany Work Group mailing list. So feel free to subscribe the mailing list. So this is my presentation. Don't forget, do we have any Q&A time?
No, we don't have Q&A time today. So thank you for this sharing. And now we are going to start the next session right now.
No problem. So if anyone have any questions, feel free to reach me via the email. Okay. So thank you, everyone. Bye bye.